Alright, what we have there is examples of enthymemes. What are enthymemes? Anyone at all?
A syllogism with a missing proposition.
Very good. What is a syllogism?
A two-premise, one conclusion argument.
Yes. You don't have to say the one conclusion. All arguments are one conclusion, but yes, that's right. So, a syllogism is a two-premise argument, which means that it consists of three propositions, the two premises and the conclusion. And an enthymeme is a syllogism with one of the propositions missing, unstated. So, of course, it consists of two given propositions. Now, these are all examples of enthymemes. So, they will just have two propositions in them. Shabbat, could you read out number one, please?
Trees need water because they are plants.
Okay. What is the conclusion of this argument?
Trees need water.
Trees need water. How many trees?
Just trees.
No, I want to know how
All
many.
of them.
All or some?
All of them.
All of them, according to this. So the conclusion is, with letters, first word, all, I'm sorry, yes, it's an A type, but all, S, R, P. How do you know it's S and P?
Because that's where they get their titles from.
Yes, because it always is in the conclusion. So in this case, S represents what? Trees. And P represents
Things that need water.
things that need water. Okay, which tells us, what is the third term? M, which stands for,
Plants.
yeah, stands for middle, and in this case it's plants, yes. All right. So we've got the conclusion, all SRP. That means the premise that we're given is they are plants. What is the they? Trees. Given that the they is trees, which premise is that? Major or minor?
Minor.
Minor. How do we know it's minor?
Contains the minor term.
Because it contains S, which is the minor term, so it comes second. How would I write that in letters? I mean like this.
All SRM.
All, because when we're saying they are plants, we're saying trees are plants. How many trees are plants? All of them. All trees, which is S, are plants, which is M. Okay, now, what we don't know is what the major premise is. What do you think the implied major premise is? Remember, when we talked about missing premises in a previous chapter, there was a reason why they were missing, and that's because it's obvious, or it's an assumption everybody shares. What's the implied assumption that everybody knows? All, yes, we know that it's the major term, so it's going to involve these two terms. And the implication is all plants are things that need water, which would be all M, R, P. Okay, what type is that? First, so give me letters. A. All right. Now, what is that called? The what of this syllogism?
Mood.
The mood. What are we missing?
Figure.
The figure. What little drawing do we need to remind ourselves of the figure?
Silly hair sunrise there.
The stupid spiky hair drawing. Yes. And what does that tell us? It's 1, because what do the lines represent?
The ends.
The M. So we draw a line through the M's and it looks like this. So that's 1, 2, 3, 4. Okay, so it's AAA1. Valid or invalid? Well, it's valid. It's actually like the Chihuahua argument. But let's remind ourselves of how to test whether or not it's valid. how do we work out whether or not a syllogism is valid? The rules. How many rules are there? 4. Okay. Rule number 1, without looking, Nick, is what?
That was one I was having trouble with.
Well, the first 2 are to do with what?
Distribution.
Distribution. That's right.
So, if
Now,
it's got to be distributed in one of the first 2 premises.
what does?
The M.
The middle term,
Yeah,
yes.
that's it.
The middle term must be distributed in one of the premises. All right, let's look here. Is M distributed here? Well, how do we tell? What is M here? Is it the subject or the predicate?
Predicate.
Predicate. What is the rule for when the predicate is distributed?
Distributed when negative.
Yes. All right, Don, I'm going to have to ask you to be silent because you're answering all the questions. Yes, the M is distributed when it's negative. Is this negative? No, so consequently M is not distributed in this premise. Does this prove that the argument fails rule number 1? Not yet. Why not? Yes, it only has to be distributed in one of the premises. Is M distributed here? Because it's the subject of... When is the subject distributed? When the categorical proposition is?
Universal.
Universal. And this is universal. So this passes rule number 1. Rule number 2, without looking it up, Hyungyu. What's that?
I can remember that.
It's to do with distribution. We've covered the distribution of M, so now we need to talk about the distribution of S and P. If the term is distributed, zip it, in the conclusion, then it must be
distributed in the premise in which it occurs.
That's right. I know you could have said that, Don, but you don't get to. All right. Now, is P distributed in the conclusion? Everybody but Don.
No.
No. Why not?
Negative.
Because it's not negative. The predicate is only distributed when the predicate is only distributed when the categorical proposition is negative, and it isn't. So that means we don't care about it. We don't have to check. It's only if it's distributed in the conclusion that we have to check. Is S distributed? Everybody but Don.
Yes.
Yes. Because it's universal. The subject is distributed when it's universal. Now, if the subject was not distributed in the minor premise, what fallacy would this argument commit? Well, it involves the word minor. Illicit minor, yes. Does this commit illicit minor? No, because it is distributed, because just like in the conclusion, it's the subject of the universal. All right, so what does that mean about rule number 2? Thumbs up. Oop, and break the chalk. All right, rule number 3, Zach. The premises cannot both be negative. Are the premises both negative? No, so this passes rule number 3. 4, Brian, not Zach.
If one of the premises are going to be negative, then the conclusion has to be a negative.
And vice versa. Yes. Well, as they're all affirmative, this doesn't come up, so bingo. What have we proved?
It's a valid argument.
It's a valid argument. What does that mean? Why do we care whether or not an argument is valid? Or why do we pretend to care to make our teacher happy? You're not doing a good job of pretending. Why is validity important? Yeah, what is true of a valid argument? I know, you're biting your it's painful, isn't it, Don? Don knows the answer, why don't you? When is an argument valid?
When it supports the conclusion?
More than that.
Alright.
The premises are always supposed to support the conclusion. In a valid argument, the premises guarantee, stop it, guarantee the conclusion. Yes. So it's the sign of a logically good deductive argument. That's why we care about validity. Let's do one more of these, just because it's good practice. Number 2, destiny.
I have a question on this one.
Oh, sure.
When we're filling in the missing premise, how do we know that M is going to be on the left as opposed to on the right side?
Well, in this case, in this case, it was kind of a gut call. In fact, that's what we're doing in this exercise. We're just saying, well, what seems to be the implied premise? So we have a choice. All plants are things that need water, or all things that need water are plants. Which seems more obviously true?
All things, or all plants are things that need water.
Right, so that's how we chose.
In cases that aren't like inherently obvious, is there a different way to check?
Well, if it's not obvious, then probably there will be a different question asked, which will be, what would it have to be to make this argument valid? And that's a little trickier to work out. Let's see what happens if these are the other way round. All things that need water are plants. Would this be a valid argument? Well, actually no. It would commit what fallacy? We have a name for this one. No, it's not illicit major, because it can't be illicit major because the major term is not distributed in the conclusion. It can only be illicit major if it's distributed in the conclusion but not in the premise. Doesn't matter if it's the other way around.
Undistributed middle.
Undistributed middle, that's right. Because now the middle term is undistributed in both premises. So that's why this one would be a bad choice, because it makes, ideally a missing premise will make the argument valid, and this one wouldn't. Okay? All right, Destiny, could you read number 2, please?
No one who is dishonest will be happy, since a dishonest person lacks character.
If only this were true. Sadly, dishonest people are often happy. What's the conclusion?
No S or P.
No what?
No S.
No S or P. Okay, and what is S in this case?
No one.
Well, keep going.
No one who is dishonest.
Yes, so dishonest people. S is dishonest people. What is P? So we've said no, dishonest people are, what is P? Happy things. Actually, to be perfectly precise, it's things that will be happy. That's what it says. Things that will be happy. So what is M? Yeah, we have a choice to make here. We have been given the conclusion and one premise. Which premise have we been given? Major or minor? Raise your hand if you think you know. What is it?
The minor.
We've been given the minor premise, you say. Somebody who isn't Zach or Brian, or Don, tell me how we know. Yes?
Well, because in the conclusion it says that the minor term is dishonest people, and that's what's used in that.
Exactly. So we know what the minor term is, and it's contained in that premise, so that makes it the minor premise. So, now, is this a universal or a particular premise? A dishonest person lacks character. How many dishonest people are we talking about? Are we just saying that dishonest person over there lacks character, or are we saying it's true of all dishonest people? All. So it's universal. Is it A or E?
A. E.
Why do you say E?
Because it's no dishonest people or things. Wait, articulate the conclusion.
No, we're talking about a dishonest person lacks character. That's what we're talking about. Well, it sounds like A, but why am I going to say it's E?
Because no dishonest people, wait,
No.
no.
Because of the word
things
lacks.
that lack-
Why is that relevant?
You have to reword it as are, like, all SRP or no SRP, or the way you have the predicate set up, things that where the middle term, you have to like.
Well, the predicate, yeah, when you're defining a term, in this case we're defining, the term we're defining is M.
Right.
What do we want to do? We want to define it positively, right? Remember, you know, we don't want to define a term as things that are not bricks or something like that, because that's stupid, you know, we don't care about, that's a weird way to define a term. So there's a rule that you should define it, except in, you know, in some cases it can't be avoided. There are some things that are by their nature negative. But in this case, let's just follow the rule and say that we're going to define the term as things that have character. So if M is things that have character, what type is dishonest people lack character? It's E, because it's saying no dishonest person is a thing that has character. So it's no SRM. All right, now we have a missing premise. What two terms is it going to involve? P and M, because it's the major premise. So it's talking about, it's connecting having character with being happy. What do you think it'll say? In words, you don't have to.
All MRP.
That's not words. Well, some of it was words, but I want all words.
All things that have character are things that we have.
All things that have character are things that will be happy. Yeah? So all MRP. Now, we chose that because we think that might be what makes it valid. We were, well, not all of us think that apparently. Eric is disagreeing, but let's test to see whether or not we now have a valid argument. Rule number 1. Eric, what is rule number 1 again?
Distribution of M.
Yes, what is it? The middle term, what is the rule? It concerns the distribution of M, what is it? The middle term must be...
No.
Ah! Terms cannot be valid. Only arguments can be valid. The middle term must be distributed. Where?
And at least one premise.
In at least one premise. Is the middle term distributed? It's actually distributed in both. Why is it distributed here? Because this one is negative. It's the predicate of a negative. Why is it distributed here? Because this one is universal. So, passes rule number 1 with flying colors. What's rule number 2, Ken? Also about distribution. We've covered M. Jordan? Without peeking, Ken could have done that if he was allowed to peek. If a term
It is distributed in the conclusion.
Then?
Distributed in the premise which it occurs.
Yes. Is S distributed in the conclusion?
Yes.
Yes. Is it distributed in the minor premise? Yes. Is P distributed in the conclusion? Because it's negative. Is P distributed in the premise? No. So what fallacy does this commit? Illicit major. Uh-oh. We didn't pick the right missing premise. How can we fix things? Eric, are you going to tell me?
No, I have a question.
Okay.
How is the S distributed?
Because it's the subject of a universal.
Oh, it just has to be universal. Okay.
Yeah. That was an easy question to answer.
Yeah.
I like those. All right, how are we going to fix this? Yes?
Small PRN.
Yes. Because in fact, what we really want to say is only things that have character will be happy. And what is the way, but we can't use the word only. We're only allowed to use the word all or no. So how do we say only things with character will be happy? Well, the answer is we say all things that will be happy have character. Here's another way to think about it. If I say only cool people take logic, which is of course true, the way to say that as a universal is all people taking logic are cool. If only cool people take logic, then what do we know about every single person taking logic? They're going to be cool. So, all PRM. Now that we've changed that, does this commit illicit major? No, because now P is the subject of a universal, so it is distributed. All right, so let's keep going. Oh, and what do I have to change? Oh, I never even said what the mood and figure was. All right, give me 3 letters. And what is the figure? 3 or 2? 2. Because remember, the hair clumps in the middle. So if it's on the right, it's 2. If it's on the left, it's 3. So it's AEE2. All right. What's rule number 3? Philip. Doesn't involve groaning. It does involve negativity. Both premises.
Both premises.
Or you can't have.
Well, they can't both be negative.
Yes, you can't have both premises be negative. Does it pass rule number 3? Yes, it does. Samantha, what's rule number 4?
If one premise is negative and the conclusion has to be the other way around.
Does it pass that? Yes, so that one is valid. Good. All right. Now, let's move on to new stuff. What are we going to learn today? We are going to learn another method of testing for validity that involves those wonderful things, Venn diagrams. Venn diagrams are awesome. I will brook no objections to that claim. It is just true. How are we going to use Venn diagrams to test for validity? Well, we know how to use Venn diagrams. We know how to use Venn diagrams to represent the information in a categorical proposition. What we don't know yet is how to use them to represent the information in a categorical syllogism. Well, let's look at let's do AEE2. So AEE2 AEE2 looks like this. All PRM, no SRM, conclusion, no SRP. All right, what we're going to do now is use Venn diagrams to represent that information in that categorical syllogism. Now, the conclusion is no problem. We just do it as we've always done. So what do I label these 2 circles? S and P, that's right. Yeah, I'm going to make you be quiet for the whole class, though. It's going to be cruel. All right. But the problem now comes with the premises. I could represent the premises as 2 other separate diagrams, like one involving P and M, one involving S and M. But that wouldn't be much good, because then I would just have 3 distinct propositions, and why would that show me about validity? So what I'm going to do, well, let's work out what we're trying to do first of all. When is an argument valid? When, we've already said this, the premises guarantee the conclusion. So if we're going to use diagrams to test whether an argument is valid, what we should do is we should represent the conclusion with one and represent the premises with another. So I want one diagram to represent the information of the premises. How many circles am I going to need? 3. That's right. Why? Because there's 3 terms in the premises. S, P, and M. Okay, well S and P are going to be in exactly the same place they always were. Here's S, here's P. But we need M, and the place to put M is up top, here. So it looks like the back of a Led Zeppelin album. I gotta stop saying that. I mean, not only that it does involve Led Zeppelin, but it involves the word album, and people don't know what those are. Alright. Now what do we do? Well, we use these diagrams to represent the information then. It's easy to do with the conclusion. Will we be shading or putting an X? Everybody? How do we know? It's universal. What does the shading represent? Nothing there. It represents emptiness, void, vacuum. Now, there are now only actually 3 possibilities of regions. We used to have 4, but that only came up when we were talking about nons, like non-S and non-P. But if we're not talking about nons, which we never are, now we're talking about syllogisms, the shading is always going to be within the circles. In fact, I already know, because the subject is S, I can narrow it down to which 2 regions? 1 and 2, because wherever I shade, it will be in the subject, which in this case is S. Which region do I shade? Region 1 or region 2, if no S or P? Everybody? 2. Okay, why?
Since the overlap between S and M.
That's right, so what? Why do I shade it?
Because there's nothing there.
Because it's saying that no S or P. If this is no cats or dogs, what would be an S is the cat, dogs, and there aren't any. Alright, so I'm going to shade this region. Incidentally, whenever you're shading now with categorical syllogisms, you will always, always, always be shading either a cat's eye shape or a gibbous moon shape, which is like the rest of the circle. Did you know that's the name of that? Gibbous moon. There's new moon is the little sliver, full moon is the full circle, gibbous moon is the bit with just a little bite taken out of it. Live and learn. Alright. Now I'm going to diagram the premises. This looks a little complicated, but in fact you already know how to do it, because we're not going to try and diagram both at once. We're going to just take them one at a time. So let's start with the major premise. There's only 2 terms there, so it's just like any other categorical syllogism. Bless you. Which circle am I going to ignore then? S, because S is not featured. So all I care about is P and M. Now, am I going to be shading or putting an X? Shading, because it's universal. Am I going to be shading the top moon, the cat's eye, or the bottom moon? Bottom moon? See how I can make you say stupid things? Yes, bottom moon. Why am I shading the bottom moon?
Nothing exists in P except M's.
That's right, all the P's are inside of M, so what would be in P is the P's that are not M's, but we know there aren't any. So, I'm going to shade here. Now, I'm going to do something purposely wrong, and you tell me what it is. What have I done wrong? Yes, I haven't shaded the whole moon shape. If you find yourself shading something that looks like a cookie with 2 bites taken out of it, you screwed up. If you find yourself shading something that looks like a cookie with no bites taken out of it, you also screwed up. It should look like this or a cat's eye. Okay. So that's the major premise diagram. Now what have we got to do? The minor. It's killing you, isn't it, Tom? You can get through this. Alright. What circle am I going to ignore now? P, because it is not mentioned. So, I'm going to be shading either, I'm just going to be looking at S and M. I'm either going to be shading the top moon, that is M but not S, the cat's eye, which is the overlap, or the bottom moon, which is S but not M. So, top moon, cat's eye, or bottom moon? Which is it? What's that again? cat's eye. Why?
Because it's a constant pair between.
Yes, because it's no S or M. There is nothing that is in both. Good. Good use of colors, I think you'll agree. See what you made me do? I'm down on my knees here. All right, now we have finished the diagram. And the diagram tells us something. It's like tea leaves. If you know how to read it, there's important information there. It tells us whether or not this argument is valid. What is it telling us and why? Well, let's remind ourselves, once again, because it's the most important concept in the class, what it means to be a valid argument. When is an argument valid? When the premises guarantee the conclusion. Let's remember the example I was used. All chihuahuas are dogs, all dogs are mammals. Now, when I said the premises, you were able to tell me the conclusion. Why? So I told you all chihuahuas are dogs, all dogs are mammals, and you told me.
Premises.
But what was the conclusion? If all chihuahuas are dogs and all dogs are mammals, then all chihuahuas are mammals. How do you know that? It's contained within the information. I've already given you that information. If I tell you that all chihuahuas are dogs and all dogs are mammals, I have in effect already told you that all chihuahuas are mammals, right? So that's what happens in a valid argument. In a valid argument, the reason why the premises guarantee the conclusion is because the premises contain the conclusion. Any information that is in the conclusion is contained in the premises. With that in mind, what is this diagram telling us? Yes? Brian, not Zach.
Yeah, the empty space that's in the conclusion is included as empty space in the premises.
Right. In other words, what we got to do, here's how we do it. You look at the conclusion and you ask yourself, what information is contained in the conclusion? Now, in Venn diagrams, there are only two kinds of information. Shading or an X. This is not information. We don't know. This is could have stuff in it, could have not, we don't know. So the only positive information in this case is shading. So we look at the region that is shaded. It is the overlap between S and P. This argument will be valid if that information is contained within the premises. Is that information contained within the premises? Yes, because look, here is the region, the overlap between S and P. Is it entirely shaded? Yes, it is. Now, of course, the premises will have more stuff in them, but we don't care about the more, because there's two premises. Of course, they're going to say more than the conclusion. All we care about is, do the premises say less than the conclusion? If the premises don't include everything that's in the conclusion, then it's not a valid argument. The premises can't guarantee it. Knowing that the premises are true wouldn't guarantee that the conclusion is true. But the premises do, in this case, contain all the information in the conclusion. So if the premises are true, the conclusion has to be true, because it's just saying what's already said in the premises. So this illustrates a valid argument. Does that make sense? Okay, and notice how you have to have both premises. If you just had one premise, then this bit would be missing. If you just had this premise, then this bit would be missing. It's only when you put the information of both premises together that you guarantee the conclusion. So they're dependent premises. Neither one can guarantee the conclusion without the other. Okay? All right then. Try that with AAA1. No, try that with AAA2. Sorry. Oh, my old knees. when you're drawing Venn diagrams, make sure they overlap to a significant degree so that you can see this in the overlap. I mean, if they're just, you know, very small and cramped, you won't be able to tell whether regions are shaded. Now my circles are messy, but they at least overlap to a significant degree. Alright, what do we diagram first? The conclusion. Are we shading or putting an X? Shading because it's universal. Where do we shade? Do we shade left moon, cat's eye, or right moon? What's the answer? Left moon. Why?
All SRP.
Because all SRP. See how fast I did that? Alright. Now, it doesn't matter which order we do the premises in, so let's just do major premise first. Are we shading or putting an X? First of all, what circle are we ignoring? S, because it's not mentioned. So we're just looking at P and M. Do we shade the top moon, the cat's eye, or the bottom moon? Why? Because all the P are in M, so that part of P will be empty. Okay, now we're going to do the minor premise. So what circle do we ignore now? P, because it's not mentioned. So we just look at S and M. Do we shade the top moon, the cat's eye, or the bottom moon? Bottom moon, because we're shading the part of S that is outside of P. We're done. Is this argument valid? No. What? Who said no? Okay, Josh, come up here and point to the part of the diagram that tells us that this argument is not valid. Exactly right. Why is that right? You can go back there.
Because there's things in it that are shaded.
Because in the conclusion is giving us information. That region is shaded in the conclusion. For this to be a valid argument, it would have to be shaded in the premises. But it's not. So that proves that these premises do not guarantee this conclusion. So it's an invalid argument. Okay? Yes? We all know how to read Venn diagrams like tea leaves? Alright, now so far we've just looked at one kind of Venn diagram. I'm sorry, one kind of syllogism. A syllogism where all three propositions are what? Universal. We haven't yet looked at examples where the propositions are particular. So, let's do that. I want you to work out what I003. What would that be? Work that out now. You don't have to diagram it yet, just work out what it would be. Jacob, what is the major premise of this argument?
Some PRM.
Who disagrees? Okay, your hair is not clumping in the middle. What should it be? Some MRP, because if you look at the hair, there should be, yeah, it clumps in the middle. So when both m's are on, so for number 3, both m's are on the left. So it would be MP, MS, like that. So it's some MRP. Okay, Zainab, what is the minor premise? Yes, some M are not S. It's an O type, so it's some are not. And then finally, the conclusion, Hunter, is?
Some S are not P.
Some S are not P. Good. All right. Now let's diagram it. Once again, it's going to look. Our diagrams are going to look the same. We have one regular old diagram for the conclusion, and then we have the 3-circle system for the premises. S, P, M. Okay. Start with the conclusion. Shading or putting an X? Because it's particular. Do I put my X in the left moon, the cat's eye, or the right moon? Everybody. Some S are not P. What is it? Not the cat's eye. That would be some MRP, right? So we know it must be somewhere in S. So we know it's either the left moon or the cat's eye. But it's saying some S are not P. So it must be in S, but not in P. So it's here. Right? Yes, that's right. Okay. Now, let's do the major premise first. So, first of all, we ignore S. However, unlike with the universal, we don't totally ignore it. We ignore it for now. Okay, some MRP. I'm going to be putting an X either in the top moon, the part of M that is outside of S, the cat's eye, which is the overlap, or the bottom moon, which is the part of S that is outside of M. Where am I putting my X? The cat's eye. Because it's some MRP. So it says there's something that is both in M and in S. So I put it somewhere in this region. Right?
Wait, did you say M and P?
M and P, yes. Yes. Well, yes, actually, because it's okay. Oops. All right, I put it somewhere in this region. This one, right here. Ignore this one. That was stupid. We regret that now. All right, we put it in this region. Now, where in this region? Well, it matters where I put it in this region. I have to put it somewhere in this region because I know that there is some M that are P. But if I put it here, I am indicating that I have knowledge that in fact I don't. Because right now, I'm acting as if I only know this one. I don't even know, I haven't read this one yet. So I can only represent information in this one. But if I put an X here, it's as if I'm saying I know that there is something outside of S. So in effect, it would be in non-S. Whereas if I put it on this side of this line, I would be saying that I know that there is something in S. But I don't know that, because I don't know anything about S. And this will have important implications for the conclusion. So what am I to do? Where can I put my X to avoid making any call on S? Yes?
On the line.
On the line, exactly. Right on the line of S. Not on the line of either of the terms we're talking about. You never put an X on the line of any of the circles you're talking about. So I have to put it entirely within this region of M and P. But within this region, I find where this third circle, the circle that is not mentioned in the premise that I'm diagramming, I look for where that passes through the region, and I put my X on this line. That way, I avoid committing myself either way on S, and that's important. Okay, now we go to M and S, which is where I was before, and I shouldn't have been. So let's use blue for that one. Okay, so now we're looking at M and S. Shading or putting an X? X because it's particular. Am I putting it in the top moon, M but not S? The cat's eye, both of them, or the bottom moon, S but not M? Top moon, because it's got to be in M, so I know it can't be the bottom moon, but it's not in S, so it can't be the overlap. So I put it somewhere in this region. Where in this region? It'll be on what line? The line of what circle? P. So I put it somewhere entirely within this region, but where this line passes through it. So right here would do. Okay? Is this a valid argument? We have a confident no. Why not, Jordan?
Well, it doesn't match, so.
It doesn't match, that's right. Because if it's a valid argument, then the information in the conclusion will be in the premises. What is the information in the conclusion? It's an X in the part of S that is outside of P. Is there an X in that region in the premises? No. All right. Suppose, though, we had something like this. Here's the conclusion. And suppose we had, let's see, something like this. Incidentally, see if you can work backwards to work out what syllogism this would be. There's an exercise for you. What's the conclusion? What's that? Some SRP. What are the premises? Actually, for each premise, there's two things it could be. What's this one? What's the major premise? Some MRP, or alternatively, yes. Let's say some MRP. And then what's the minor premise?
Some S
Or?
some MRS.
Yeah, so actually we know it's going to be I, but the figure could be 1 through 4, right? Because each one of them can be either way. So some MRS. So that would make it I 3. Now, is this valid? Well, you might sort of be tempted to say so, because there's 2 halves, right? And you might think, well, 2 halves make a whole. But no, it doesn't. That would be like finding, 2 severed torsos on a beach and saying, we found a person, right? No, 2 halves do not make a whole. It has to be an entire one here. Now notice, suppose you are diagramming some MRS. You knew that the X went in here, and you were making a judgment call. If you put the X in here, what would that make the argument? Valid. And if you put the X out here, it would obviously not be valid. So, we can't be left to a judgment call what you did, because it'll affect whether or not it turns out valid. Which is why we make the rule that you have to put it on the line. And then it's clear that this argument is invalid. What do you think is true of all arguments like these two, where it's just particulars? They're not valid, because you're always going to be putting X's on lines, and you're never going to have them entirely within regions. So no argument where all the propositions are particular will ever be valid. All right, we've done all universal, we've done all particular. What's left? A mix of both. All right, let's look at one of those. Work out what EIO3 would be like. I call this the old MacDonald syllogism. And nobody ever laughs. Jamie, what is the first premise of EIO3?
No MRP.
Yep, that's right. Chris, what is the second minor premise?
MRS.
That's exactly right. Don, you were allowed to speak for this one. What's the conclusion?
Some S and not P.
That's right. Okay. Now, notice we have a combination of universal and particular. We've got one universal premise and the rest are particular. Let's see how we do this. Well, first of all, we always start with by diagramming the conclusion. Am I shading or putting an X? X because it's particular. I'm putting it in the left moon, cat's eye, or right moon. Everybody. Left moon because it's in S, but it's not in P. So it's like that. Okay. Now, write this in your own blood, because this is important. This is a golden rule. Here we go. See, I'm writing it in my own blood. It's red. All, better make it short so that you don't pass out. Always, actually, always diagram. Anyone remember that Simpsons episode where Sideshow Bob is in jail and he's writing threatening letters in his own blood to Bart, and he gets too wordy and runs out of his own blood and passes out? His cellmate says, "Use a pen, Sideshow Bob." Always diagram the universal premise first. That is the rule. Now, of course, that doesn't affect what we did before, because when there's two universal premises, which is what we started out with, it doesn't matter the order. If there's no universal premises, which is the ones we've just been doing, then it doesn't matter the order. The order only matters when you have a mixture, like you do here. So which diagram am I going to be diagramming, which premise am I going to be diagramming first, the major or the minor? Major. Let's see what happens if I do it the wrong way. So, let's say I'm going to diagram this one first. Some M are S. Shading or putting an X? X. Where do I put it? In the, so, I'm looking at M and S. So here's M, here's S. Am I going to be putting it in the top moon, the cat's eye, or the bottom moon, if some M are S? Cat's eye. Whereabouts in the cat's eye?
On the border of the P.
On the line of P. So if I was doing this one first, I would put it there. Right? What would I already know about this argument then, if that was right?
Some classes could be with these.
Well, valid or invalid? It would have to be invalid. Why? Well, because there's an X in this region in the conclusion. Is there an X in that region in the premises? No, there's only half an X. Well, you think, well, maybe there'll be, I'll fix it with the other premise, but I can't. Why not? Because you're shading, there's no X. So there's only going to be one X. And if it's not in this region with that premise, it's not going to be valid. But I happen to know this is, well, no, I'm not going to, well, too late. But anyway, that's what would happen if I diagrammed the particular first. But I'm not going to do that. So we're going to pretend we don't see that. I'm going to diagram the universal first because of this nice golden rule here. Am I going to be shading or putting an X? Shading because it's universal. Where am I going to be shading? Top moon of M but not P. Cat's eye, which is both, or bottom moon, which is P but not M. Cat's eye, because I'm saying there's nothing that is both. Alright, now we already know, because we worked it out, that I'm going to be putting an X somewhere in this region. And before I shaded it, I said I'd have to put it on this line. Why don't I put it on the line now?
Because now you can definitively say that it's not.
That's right, because what was the reason for putting it on the line before?
Could have possibly been here.
Because, yeah, I didn't know whether it was in either of these two regions. But now that I've done the shading first, I know it can't be in here. Why not? Because shading means it's empty. So I know there's nothing in this region, so there's no way my X could possibly be in here. So I don't have to have any doubts. I can safely and confidently put it in this part of the cat's eye. Remember, it has to be in somewhere in the cat's eye, but it can't be in the empty region, so it has to be somewhere here. What difference does that make to our final decision? Now we know that it's valid, because it doesn't matter that it's up in the corner here. Don't worry about that. All you care about is, in the conclusion, there's an X somewhere in the moon part of S. Is there an X somewhere in the moon part of X? S? There it is. So this argument is valid. So that's why you shade first, because it can bump an X off a line and potentially make it valid. All right. How much time? All right. Try this one. AII1. AII1. You have 3 minutes. Go. Some S are M, some S are P. Everybody got that, I hope? Good. So we know some S or P goes like that. Now, which premise do we diagram first? Major or minor? Why? Because what you wrote in your own blood. Because of you diagram the universal premise first. So are we shading or putting an X? Shading because it's universal. Top moon, cat's eye, bottom moon. Top moon. Yes, so we shade this region. Now, with this one, we're putting an X. Where do we put it? In the part of S outside of M, in the part of M outside of S, or the cat's eye? Cat's eye. Now, normally, we would put it on the line. Do we now?
No.
Why not?
Because the left side is nothing there.
Because the shade, we know that this region is empty, so it bumps it off the line and puts it there. And this tells us that this argument is? Everybody, this argument is? Yes, because there's an X in the conclusion there, and there's an X in that region there. Good? All right. Now, one more. Please do AAI1. So one difference. Instead of AII1, it's AAI1. What do you think this is going to be? Invalid. We'll see. Alright, who's finished? Valid or invalid? Why is it invalid? How is it you guessed that it was going to be invalid?
All, just have some of that.
Right, because what are we going to be doing for both premises? Shading. What are we going to be doing for the conclusion? Putting an X. So this can't be valid because the information in the conclusion is that there's an X somewhere. But there's no X's at all in the premises. So clearly, this is an invalid argument. Well, let's double check, shall we? What's our other method of testing for validity?
The rules. Or the 5 rules.
4 rules. Don't choke the gun.
Okay.
4 rules. Okay. First rule is, well, Ethan.
Yeah, it needs to be distributed in at least one premises.
Is M distributed here? Is M distributed here?
Yes.
So it passes the rule number 1. Second rule, Josh.
If a term is distributed, then the conclusion has to be distributed in
Do we even have to look at the premises? Why not?
neither of them.
Because neither term is distributed. If it's an I-type, you know it's particular, so the subject is not distributed, and it's affirmative, so the predicate. So it passes rule number 2. Rule number 3 is what, Jeff? To do with negativity?
If one's negative, if the premise is negative, then the conclusion has to be negative as well.
That's rule number 4, but yes, that's fine. And does it pass that rule? Yes, because neither, there is no negativity. Cat, you've had a chance to peek. What is the third rule?
Both premises can be negative.
And it passes that rule. Uh-oh, what's the problem?
Passes everything.
The rules say that it is, but the diagram says that. What the hell's going on? Well, the answer is to do with a dispute about a little something called existential import. Trips off the tongue, doesn't it? Existential import. Specifically, the existential import of categorical propositions. Now, believe it or not, the whole debate hinges on unicorns. Well, not really, but I can give a good example using unicorns. Here's the problem. What do we assume about every single proposition? What is the defining feature of propositions? They have truth value. How many truth values are there? 2. So we assume in logic that every proposition is either true or false. Not some vague gray area between the two. It's either true or it's false. Okay, here is a categorical proposition for you. All unicorns have a horn. Let's say all adult unicorns, because that would be a difficult birth. Okay, so all adult unicorns have a horn. True or false? Got to be one or the other. You know what it means, right? This is, I'm not just saying gibberish, so this is a meaningful categorical proposition. You know what it means. You should be able to tell me the truth value. What is it? Who says true? Nobody says true? Come on, be bold. Raise your hands high, unicorn lovers. Alright, who says false?
Can you define the term first?
You don't know what a unicorn is.
I just want to see your definition.
There you go. A unicorn is a mythical creature
Okay.
that resembles a horse with a horn. Incidentally, where did the myth come from, do they think? An equally ludicrous but actually existing creature, the narwhal. A narwhal is a whale unicorn, right? I mean, It's just as crazy as a horse unicorn, but it actually exists. Narwhals are whales that have a unicorn horn, a very long, spirally classical unicorn horn. And the assumption is they found narwhal skulls and thought they were horses or something like that. But anyway, all right. What's the problem? Why can't you give me a straight answer? Why are you all dithering about the truth value of this proposition? Because unicorns don't exist. You could have said that a bit more gently, because you've broken it to some people. Now they're going to have to go home and burn their lunchboxes. Yes, that is right. Destiny, you are correct. There are no unicorns. So what?
But in like, okay, let's say like a book, like let's say Chronicles of Narnia or something. There's unicorns in that book, and they have horns. So like.
Yeah, I mean, what is a unicorn? Picture a unicorn. Are you picturing something with a horn? Yes, you are. So unicorns, by definition, have horns. So it seems like we want to say it's true, but then it seems like we don't want to say it's true. The reason why we don't want to say it's true is because we are troubled by this. The existential import of a categorical proposition is what implications, so import here is in the sense of implications rather than bringing into a country. So the implications that the truth value of a proposition has for what exists. Okay. If we say that universal categorical propositions have existential import, then what we're saying is, if they're true, that means something exists. Okay? Now, the assumption in classical logic is essentially that universal categorical propositions do have existential import. That means if it's true that all S are P, it means that there are S's. S's exist. That is why, incidentally, let's remind ourselves of something we learned that assumes classical logic. Classical logic is the logic assumed by the ancient Greeks. What did we call this shape? Square of opposition. And we learned, what is this relationship called? No, it's not called sneeze. Contraries. This is called subcontraries. And this is called, nothing. Because nothing goes that way. That's subalternate. All right, gets you every time. Now, and we also, of course, learn contradictories. What do we know about contraries? They can't both be true. So you can't have this, right? And we learned that if this one was true, that one had to be true. Why? Well, because suppose this said that all unicorns had horns, we're assuming that means that unicorns exist. So of course, that implies that some unicorns have horns, right? Well, that's the assumption of classical logic. Modern logic is the logic of Venn diagrams. And according to Venn diagrams, not all categorical propositions have existential import. Guess which ones do? Remember, what does the X mean? Something's there. What does the shading mean? Nothing's there. So what kind of categorical propositions have existential import? Particular ones. Because if a particular one is true, it means there's something there. Something exists. Whereas universal ones do not have existential import. Why not? Because they're just saying that there's nothing there. Let's work out the truth value of all unicorns have horns. It looks like this. This is unicorns, this is things with horns. In fact, in the real world, as it actually is this true? Yes, Samantha, you nodded your head. Why is this true?
Because they all have horns.
Well, but unicorns don't exist. But why is this true? What is this in fact saying? What does the shading mean?
There are no unicorns that don't have horns.
Yes, this in fact means that there are no unicorns that don't have horns, because this would be the unicorns that don't have horns, and it's empty. Is that true? Yes! Horses are not unicorns without horns, okay? Why is this true? Because there aren't any frickin' unicorns, right? So of course there aren't any unicorns without horns. So this is true. What is the truth value of this? what does this say? This says there are no unicorns with horns. Is this true or false? No, it's true. Why? Because there are still no freaking unicorns, right? This just says there are no unicorns without horns. This says there are no unicorns with horns. They're both true because there aren't any unicorns, right? Right? What logical relationship have we just undermined? No, not yet. Contrary. Why? Because both of these are true. In countries, that can't happen. Now, this says some unicorns have horns. True or false in the real world? False. Why? Don't make me say it again. There aren't any unicorns. If this was true, it would say there would have to be unicorns. Are there unicorns? No. So this is false. What relationship have we just undermined now? Subalternate, because subalternate says if this is true, this has to be true. Doesn't work in modern logic. And incidentally, this is why this argument is invalid in modern logic. Because in modern logic, you can't deduce a particular from a universal, because universal just tells you what there isn't, whereas a particular tells you what there is. Whereas in classical logic, which the four rules assume, you can deduce a particular from a universal. Now, there is one way to make the diagrams and the rules line up. Ethan, what is that way?
If the conclusion is particular, then one of the premises is particular.
Which is rule number 5, which is on page 248. You just add one more rule and that will bring them into line. But classical logic just assumed the four rules, and as a result, there are more valid arguments according to classical logic than there are to modern logic. Because the classical logic says this is valid, whereas modern logic says it isn't. So I think modern logic has something like 16 valid, and classical logic has something like 24. So there's like 8 like this that are valid by classical logic, but not by modern logic. However, if you add the extra rule number 5, then they both agree. There's only 16. So rule number 5 would rule this out, because rule number 5 says if the conclusion is particular, a premise must be particular, and this violates that rule. Let's just finish this. This is true. Some unicorns do not have horns. True or false in the real world? False, because it implies that there are unicorns and there aren't. So that gets rid of this relationship. And of course, what does subalternate say? They can't both be false? Well, they are both false. So this is what you're left with in modern logic. Modern logic, you don't have the square of opposition, you have the x of opposition. Because notice, contradictory still works. The universals are both true, but the particulars are both false. And the stuff about this is in chapter, here we go. Here's the classical square of opposition on page 206. Here's the modern square of opposition on page 209. That's all you're left with. Now, the modern square of opposition is just super cautious. So why have you learned the classical? Because it applies in most cases. It works in every case where there is at least one member of the subject class. The only time it fails is if the subject class is totally empty, like when you're talking about mythical creatures. But if there's any members of the subject class, then by all means use the classical square of opposition. That'll work. It only fails in cases like that. But if you don't know what S is, then for all you know, there aren't any. And so if you want to be super cautious, you use modern logic. And that's the logic assumed by Venn diagrams. And we're out of time, and don't forget to do your homework.